Hi everyone, in this tutorial I'll be explaining how to solve differentiation questions using 2020's past papers, IGCSE past papers. So the first question that I have over here is that a curve has the equation y equals to x cubed plus 8x squared plus 5x. Work out the coordinates of two turning points. Now, two turning points means, imagine if you have a curve like this, right? This is a turning point and this is a turning point, and we need to know that when there are turning points or at turning points we can say that it is also a stationary point. All right, what do you mean by stationary points? Dy by dx equals to 0 at stationary points. All right, so that means even at turning points dy by dx is equals to 0. So what will we do is that dy by dx means the gradient, right? The gradient at any point at any x value, right? So imagine over here, the gradient is equals to 0, right? Because it's horizontal line that you can see. So that's the reason why the gradient is 0. But the gradient at this point, I mean at this x value, right? It's not going to be 0. Similarly, and a gradient at that point is not going to be 0, and it's not even equivalent to this. So for this curve, unlike a straight line, curves will always be having different gradient, right? So that's the reason why we differentiate to find the gradient dy. We find dy by dx, and we don't have a single value of gradient for a curve. So at these 2 points we can see that they both have horizontal gradient, right? Like the tangent to the curve at these 2 points is horizontal, meaning the gradient equals to 0, and that means dy by dx is also equals to 0. So that means we'll have to differentiate this equation, right? So how would you do that? First of all, I would like to write a general rule over here. Imagine if you have a x raised to n, where a is a constant. Okay, so what would you do is, if you want to differentiate this value, you will have to, a will stay because it's a constant. It will be multiplied by the power of the x. Okay, so it will be x multiplied by n, and x will be raised to n minus 1. So the power that was there originally or initially will be reduced by 1. And that power that was there originally or initially will be multiplied by the coefficient. So now the new coefficient will be a n x to the power of n minus 1. Something like this. I'm just giving a general rule, right? So this is what you're going to do over here as well. So y equals to, so you have a coefficient of 1 that's going to be multiplied by the power of x, that is 3, in the initial equation. Sorry, this is going to be dy by dx, all right? So be careful. Then it is multiplied by x raised to 3 minus 1. Okay? Remember, so always, first of all, the coefficient of this x will remain as it is, and it will be multiplied by the power of x in the equation y equals to, over here, x cubed plus 8x squared plus 5x. Of course, it depends on what question it is. So this 8 will be multiplied by 2, and x will be raised to 2 minus 1. So always remember, the powers will always decrease by 1. All right, plus over here 5. Okay, so in this situation we have 5x, right? And x is raised to actually 1. All right, in this question, in this term. So x will be, because we have 1, 5 multiplied by 1 is 5, so I just wrote it 5, and x will be raised to 1 minus 1. Okay, so that is basically x raised to 0, right? And x raised to 0 is 1, right? X raised to 0 is 1, plus this is going to be x raised to 1, and 2 minus 1. Okay, so 8 into 16 is, 8 into 2 is 16, plus x squared 3x squared dy by dx equals to that. So basically I can remove this and this. 3x squared plus this is your dy by dx. Okay, so basically what happens is that if you enter any value of x, right, you will find the gradient at that point x. All right, so basically we already know that at turning points x, the gradient is equals to 0. So that's why we have we will equate this gradient dy by dx that we found to 0. right? And we will find the x because we already know the gradient. We're finding the value of x at that point. So now it is just simple quadratic equation that you're going to do. So after using the quadratic formula, I have reached to these two solutions of x. X is equals to 1 minus 1 by 3 and x is equals to minus 5. So now what we need to do is that we have to find our y value. y equals to negative 22 by 27. Y equals to negative 5 cube plus 8 negative 5 square plus 5 multiplied by negative 5. Y equals to 50. So these are the two coordinates that we found: negative 1 by 3, negative 22 by 27. This was one of them, and this is negative 5 and 50. Now we are asked to find whether each of the turning points are maximum or minimum. As I've drawn earlier a curve that looks somewhat similar to this, this is your maximum point, okay, and this is your minimum point, right? So we are asked to find whether or which one is a maximum or minimum. Okay, in order to do that, what we'll have to do, this is one method of finding whether your turning point is maximum or minimum. You need to know that the dy by dx that we found out, which was 3x squared plus 16 plus 16x plus 5. Now we'll have to differentiate this, right? So when we do that, we'll have dy, set the second derivative. So we call this as the second derivative. So we'll have to find the second derivative. So this was the first derivative of y. This is a second derivative of y. So it's going to be 6x plus 16. Okay. So now what we're going to do is that we have the x values, right? So we'll have to input our x values. So first of all, we'll start with the negative 1 by 3 plus 16, and we'll see what value we get. We need to determine whether our value is positive or negative. That's what we are concerned with. So if our value is positive, we need to know that if our value of d second derivative of the x value that we have put, right, if it is positive, then that will be our minimum point. So that turning point is a minimum, okay? And if our second derivative is, after inserting the x value, is negative, then that will be our positive, that would be our maximum point. All right, so when you do this, you'll get a positive value, which is 14, okay? And positive, that means x, I don't have space, so I'm writing it here. So x equals to negative 1 by 3 is minimum, okay? And we'll have to see this, we'll have to check still to be sure. This is negative 14, so this means that it is negative, and x equals to minus 5. Remember, you don't need to actually care about these values that you get. You only care about either the value is positive or negative. And since you got negative for this, you need to know that the x, when your x is equals to negative 5, your answer for second derivative, your second derivative was negative. That means that this turning point at x equals to negative 5 is maximum. That's all for this question. Okay, so the second question that we have over here is, says that y equals to x to the power 4 minus 4x cubed. So find the value of y when x equals to negative 1. This is very straightforward. You're just going to insert negative 1 in x, in the place of x, because that is equals to x here. So that is going to be 5. Let's differentiate this equation, dy by dx, right? Differentiate y with respect to x. So we have over here coefficient 1, so 1 multiplied by 4, because we are multiplying the power, right, of x in y, right? x to the power of 4 minus 1 when you're differentiating it in dy by dx. Then 4 multiplied by 3 because the power again multiplied by x to the power of 3 minus 1. So that would be equals to 4 x to the power of 3 minus 12 x to the power of 2. So now what would you do is you can factorize this, right? And you can take away 4x squared and you will be left with x minus 3 because x minus 3 because 4x cubed 4x squared multiplied by x would be 4x cubed. 4x squared multiplied by negative 3 will be negative 12 squared. So you'll have to equate this equals to 0. I'm going to write it here now. 4x squared equals to 0. So 4x squared equals to 0 and x minus 3 equals to 0. X equals to 0, x equals to 0, that means, and x equals to 3. So now we have our x values. We'll just have to find our y values, right? And remember to take this equation, y equals to x to the power of 4 minus 4x cubed that's 0 and that's negative 27. Now in this question we have y equals to x to the power of p plus 2x to the power of q. Okay, we have dy by dx given to us, which is 11x to the power of 10 plus 10x to the power of 4. Okay, so now where dy by dx is a derived function, find the value of p and q. Okay, so as I've already told you, when I was differentiating or finding the derivative, right, or finding the derived function, that time I had subtracted when I had y with me, right? I subtracted the, you can see over here it was y in the function y, x had the power of 4, and in the derived function I have subtracted the power by 1 and ended up with 3. So 4 and 3, right? So it's very clear that x to the power of p will be x to the power of 11 because 10 plus 1 in y, when y equals to, in the y function, x will be added because we'll have a, a 1 added to it, right? Because when we will derive this function, right, we'll find the derivative of this function, we are going to subtract it by 1 to get x to the power of 10. We are not concerned with the coefficient. Over here it shows that there is no coefficient, right? So it will be as it is. And they already gave the coefficient for here as 2, so I'm writing it as 2, and x to the power of 4 is in the derived function. That means that it's going to be 4 plus 1, right? So x to the power of 11 plus 2x to the power of 5. So that means that p is equals to 11 and q equals to 5. Now you can find the derivative of this equation and you will end up with this. You can have a try and you will get this derived function itself. Okay, so in this question we have a diagram given to us and we are asked to find the coordinates of A, B and C. So you can see the points A and B are both on the x-axis and we need to know that the y value at x-axis, right, y value at x-axis is equals to 0. Okay, similarly, okay, so for now we will know that. So that means what we'll have to do to find because there is y equals to 0 at all the points on the x-axis. Okay, so x squared plus 3x plus minus 4, where y equals to 0 for a and b, we'll have to equate it to 0. Of course, we'll put y equals to 0. So this is again a quadratic equation, and with the help of quadratic equation you will have to find the x coordinates. I'm just going to write directly, but the quadratic equation that I'll just write over here, you can substitute your values from this equation. So x equals to 1 and x equals to minus 4. Okay, so obviously this is positive, b is in the positive side, right? It's in the right side, it's lies in the positive quadrants. So positive x-axis, so it's going to be 1, b is going to be 1, and the negative will be 8, so that's going to be -4. Now it's obvious, we already started with stating that y equals to 0, right? So in for both a and b, so y will be equals to 0. And for c, we need to know now. We found out for a and b, so for c, we need to know that it lies in the y-axis. So in the y-axis, we can see that x equals to 0 at all the points in y-axis, right? The x will be, this is 0, right? So x at all the points of y-axis will be 0. So x equals to 0. So if x is equals to 0 at that point, like x is equals to 0, so just insert 0 in x. So that means y equals to -4, right? So you found your y value -4, and that is 0. X. So we found the coordinates. Now we'll have to differentiate the expression that's given to us, x squared plus 3x minus 4. So the way I have told you before, over here, imagine one coefficient is there. So 2x, now 2 minus 1. Imagine there's 1 here, so 3 multiplied by 1, x to the power of 1 minus 1. Now -4 is a constant. This is very important for you to know, okay? So because it's a constant, if you differentiate a constant, your value will be 0, okay? So -0. So it's just for practice. As you will go on practicing differentiation, you'll be able to do it mentally, and you can directly come to this point. It's easy. You'll just directly write 2x plus 3. That's it. This is going to be 0, right? So this is your derived. So this is your derived function, 2x plus 3. Okay. Find the equation of the tangent to the curve at the point 2, 6. Okay. So imagine the point 2 is here, and that means that this point might be 2, 6. Okay. Just a rough guess. Okay. Imagine there is a line that only touches at the curve at the point 2, 6. Okay, so if it touches the curve at the point 2, 6, that is only touches that point, it's called a tangent, because of course it's touching the curve at one point, and we're supposed to find that tangent's equation, okay, of line. So the equation of line for the tangent, or the equation of the tangent to the curve at point 2, 6, we're supposed to find it. So we know that the equation of a straight line, the tangent is a straight line basically, okay? So it is a straight line. So the equation of a line is y equals to mx plus c. Now what is y, right? What is y? We're given the points 2 and 6, so 6 you can insert here. We're given x equals to 2, right? Because over here it's written, so 2. Now we are not given m, we're not given c. So c is the y-intercept, and we don't know what it is. But right, we need to know what m is, right? C also we know it's with a y-intercept, and we're not having any option of finding that. But m is the gradient. dy by dx is to find the gradient of the curve at any point of x. Okay, at any point of, I already have the equation of the curve, because curve, I'll scroll up, you can see that the gradient is always changing. So the gradient at this point and the gradient at this point is not same, it's different, right? So we already have the equation of the curve, and we differentiated it, so we already know that dy by dx equals to 2x plus 3. Okay, so now we're already given the x value, right? So 2 multiplied by 2 plus 3 dy by dx equals to 7. So that means our m value at x equals to 2 is 7. Now we can write 6 equals to 2 multiplied by 7 plus c. Now we can find our y-intercept, because that's the only unknown value we have. 6 minus 14 equals to, this is 14, so equals to minus 8. So the answer will be y equals to, because that's the equation of the straight line, of a straight line, and the tangent is also a straight line. So y equals to the gradient that we found, which is the gradient m. M is 7, right? X minus 8, and that's the equation of the line, or equation of the tangent. Okay, so that's all for this video. If you found this video helpful, please like and subscribe to my channel. If you have any doubt, also let me know in the comments below. Share it with your friends, and thanks for watching.